Okay, this is called the Bernoulli equation. It has to do with the Bernoulli principle. Pretty much it's hydraulics. If I push something small on one side, it's going to lift something really big on the other. But we're not learning that. We're learning how to solve this. This will come in handy in your physics class. So this is P, which is pressure, and this is rho, which is density. Rho and P are the different things. You got to make sure that you see that. V is velocity, gravity, elevation. This is a constant. So what I would do personally is I would multiply both sides by 2 and multiply all of these guys by 2 so I can get rid of that fraction so I can not freak out about it. So if you multiply both sides by 2, you get 2p plus rho v squared plus rho gy equals 2a. And I missed a 2 here, and make sure you don't do that. Now, there's rows on these guys, and I want the rows to be separate from everything else. So I'm going to put everything else on one side and then the rows on one side. So if I subtract 2p to both sides, you end up getting rho v squared plus 2 rho gy equals 2a minus 2p. Now, if you're having a hard time on number 19, this is probably the part where you don't know what to do. If you remember your distributive property, what we can do is actually distribute this a back, put this in. But what we're going to do is what's called factoring. And when we factor, let me do this right. And when we factor, what we're doing is we're pretty much anti-distributing. So we're taking the a out. Instead of putting it in, we're going to pull it out. So that's what we're going to do with rho here. So if I pull out a rho, what we're left with is v squared plus 2 gy, and that equals 2a minus 2p. So if rho is getting multiplied by all this, I'm going to divide by all this to get it out of the way. Divide both sides. So what you end up getting is rho, which is what we wanted to get by itself, equals 2a minus 2p, all divided by v squared plus 2gy. And so that's how you do it.